Assalamu alaikum, my dear student. How are you? I hope all of you are fine by the grace of Almighty Allah subhanahu wa ta'ala. I am Muhammad Golam Mortuja and I am your physics teacher. Today I will discuss with you chapter 6, the effect of heat on matter. So dear student, give your full concentration on this class. So my dear student, this is our first created question, and here you can see that the question is, if the temperature of a metallic sphere of radius 1 centimeter will increase by 50 degrees Celsius, then its volume becomes 4.1993 centimeter cube and surface area becomes 12.5874 centimeter square. Okay, that is our stem. And the first question of this stem is, what is called melting point? Do you know what is called melting point? So here the definition: when heat is applied to a solid, its temperature rises. If the temperature reaches a definite value, then the solid starts to melt, and that temperature is called melting point. Okay? Number B question is, why is air of fan felt cold in the wet body? Explain it. Okay? Now I will explain it. Okay? When we are wet, we have a substance on our skin that likes to absorb heat. So when air of fan blows, at that time we lose a lot of energy to the air molecules. Okay? When the body loses heat energy, our body temperature drops, so that the air of the fan feels cold in the wet body. I hope you understand why is air of fan felt cold in the wet body. So my dear student, this is our number C question, and here you can see that the question is, calculate the increased temperature of the sphere in Fahrenheit scale. That means I have to convert this temperature from Celsius scale to Fahrenheit scale. Okay, so at first I have to write all of this given value, and here you can see that the temperature in Celsius scale here 50 degrees Celsius. That means we can write Tc equals to 50 degrees Celsius, and I have to find out the temperature in Fahrenheit scale. That means Tf equals to what? And my dear student, do you know how can we convert from Celsius scale to Fahrenheit scale? Okay, let me explain it. We know there is a relation between Celsius scale and Fahrenheit scale, and we know that Tc by 5 equals to Tf minus 32 divided by 9. Okay, so I have to put this value, that means 50 degrees Celsius, in this equation. Okay, so 50 divided by 5 into 9 equals to Tf minus 32. So if I calculate this, then I will get 90 equals to Tf minus 32. So if I arrange this equation, then I will get 90 plus 32. So I will get 122 degree Fahrenheit. Okay? So I hope you understand how can we convert from degree Celsius scale to Fahrenheit scale, and our answer is in Fahrenheit scale 120 degree Fahrenheit. Okay? My dear student, this is number D question, and here you can see that the question is, from the stem establish a relation between coefficient of volume expansion and the coefficient of area expansion. Okay, so by using all of this given value, I have to establish a relation between these two coefficient. Okay, so here you can see that the given values are the radius of the sphere is 1 centimeter. Radius r equals to 1 centimeter. Okay. And the final volume, that means after increasing the temperature, the final volume of this sphere is V2 equals to 4.1993 centimeter cube. And after increasing the temperature, the final area of that sphere is A2 equals to 12.5874 centimeter square. And the increased temperature, here you can see that 50 degrees Celsius. That means del T equals to 50 degrees Celsius or 50 Kelvin. So at first I have to find out the coefficient of volume expansion and the coefficient of area expansion. Okay. After that, I have to establish a relation between these two coefficients. So if I want to find out the coefficient of volume expansion gamma, then at first I need the initial volume of this sphere. Okay, so at first I have to find out the initial volume. So the initial volume, we know that the formula of the volume of a sphere is 4 by 3 pi r cube. So if I put all of this value in this equation, pi equals to 3.1416 and radius r equals to 1 cube, then I will get 4.1887 centimeter cube. Okay, so here you can see that I have got the initial volume and I have the final volume. So, and the increased temperature. By using all of this value, I can find out the coefficient of volume expansion. And we know that the formula of the coefficient of volume expansion gamma equals to V2 minus V1 divided by V1 into T2 minus T1. Okay, or I can write instead of T2 minus T1 del T. Okay, now I have to put all of this value in this equation. Okay, so here you can see that V2 equals to 4.1993, V1 equals to 4.1887 and V1 equals to 4.1887 into del T equals to 50. So after put all of this value, I will get the coefficient of volume expansion is 5.018 into 10 to the power minus 5 per Kelvin. Okay, so I have already get the coefficient of volume expansion. Okay, so after that I have to find out the coefficient of area expansion. So if I want to find out that, at first I have to find out the initial area of that sphere. Okay, so here I can write initial area A1 equals to 4 pi r square. So if I put all of this value, then 4 into 3.1416 into radius equals to 1 centimeter square. So I will get the initial area. The initial area will be 12.566 centimeter square. So now, by using the initial area, final area and the increased temperature, I can find out the coefficient of area expansion, and we know that the coefficient of area expansion beta equals to A2 minus A1 divided by A1 into del T. So if I put all of this value in this equation, that means the final area equals to 12.5874 minus the initial area 12.566 divided by A1 equals to 12.566 into 50. If I calculate this equation, then I will get the coefficient of area 3.3469 into 10 to the power minus 5 per Kelvin. So my dear student, here you can see that I have already find out the coefficient of area expansion and the coefficient of volume expansion. So if I want to establish a relation between these two coefficients, then now if I divided the coefficient of volume expansion by the coefficient of area expansion, that means gamma divided by beta. Now, so what is the value of gamma? 5.018 into 10 to the power minus 5, and the value of beta equals to 3.346 into 10 to the power minus 5. So if I calculate this, then I will get 1.499, or gamma by beta equals to 1.5. Okay, so gamma equals to 1.5 into beta. So that is the relation between gamma and beta. That means that is the relation between the coefficient of volume expansion and the coefficient of area expansion. And here you can see that the coefficient of volume expansion is 1.5 times greater than the coefficient of area expansion. And my dear student, I hope you understand how can we establish the relation between the coefficient of volume expansion and the coefficient of area expansion by using this value. So dear student, this is our number 2 question, and here you can see that the stem is the coefficient of linear expansion of iron rod is 12 into 10 to the power minus 6 per Kelvin, whose length is 60 centimeter. A student observed that density become 7777.8 kg per meter cube after increasing the temperature of iron rod to 80 degrees Celsius. The density of iron is 7800 kg per meter cube. Okay. A number question is, what is called specific heat? The amount of heat required to increase the temperature of 1 Kelvin of a body of mass 1 kg is called specific heat. Okay. And number B question is, here you can see that why does take shorter time to cook in the pressure cooker? Okay, do you know why that is happened? Okay, let me explain it. During cooking in pressure, the pressure is increased by confining the vapor inside, and for this reason the boiling point of water increased. So water continues to boil at the high temperature. As the temperature is high, cooking will be done faster, and for this reason in the pressure cooker we need shorter time. Okay, dear student, this is our number C question. Okay, and here you can see that determine the length of the iron rod due to change of temperature mentioned in the stem. Okay, that means I have to find out the final length by using all of this given values. Okay, so at first I have to write all of this given value. Okay, and here you can see that the initial length of iron rod L1 equals to 60 centimeter, and the increased temperature here you can see that 80 degree Celsius. So del T equals to 80 degrees Celsius or 80 Kelvin, and the coefficient of linear expansion alpha equals to 12 into 10 to the power minus 6 per Kelvin. And finally I have to find out the final length L2 equals to what? So dear student, we know the coefficient of linear expansion's formula, and by using that formula we can easily find out the final length. Okay, so we know that the coefficient of linear expansion alpha equals to L2 minus L1 divided by L1 into del T, and then after rearrange this equation I will get L2 minus L1 equals to alpha L1 del T. So L2 will be L1 plus alpha L1 del T, and after that I have to put all of this value in this equation, and here you can see that L1 equals to 60, that means the initial length, plus alpha equals to 12 into 10 to the power minus 6 into L1 equals to 60 centimeter and del T equals to 80. Okay, here I need to use bracket. Okay, so if I calculate this, then I will get the final length L2 will be 60.0576 centimeter. Okay, so my dear student, I hope you understand how can we find out the final length by using all of this given value. My dear student, this is number D question, and here the question is it correct the observation of the student? Analyze mathematically. Okay, I have to prove that is the observation of those students is correct or not. Okay, so let's start to solve this math. And here you can see that at first I have to write at the right side all of this given value. And here you can see that the increased temperature is del T equals to 80 degrees Celsius or 80 Kelvin. The initial density or the normal density of iron rod is ρ1 equals to 7800 kg per meter cube. Okay, and the coefficient of linear expansion of rod, here you can see that alpha equals to 12 into 10 to the power minus 6 per Kelvin, and I have to find out the final density. So I need to find out the coefficient of volume expansion. Okay, that's why the coefficient of volume expansion gamma equals to, we know that 3 alpha equals to 3 into 12 into 10 to the power minus 6 per Kelvin, and the gamma will be 36 into 10 to the power minus 6 per Kelvin. Okay, and finally I have to find out the final density, and after that I have to match this final density with that density. Okay, so final density rho 2 will be what? Okay, so my dear student, at first here you can see that before increasing the temperature, what is the density of the iron rod, and after increasing the temperature, what will be the density of iron rod. I have to write these two equations. Okay, and here you can see that before increasing the temperature, the density rho 1 equals to m by v1, and this is number 1 equation. And after increasing the temperature, rho 2 equals to m by v2, and this is number 2 equation. And here you can see that, dear student, look at this 2 equation, and this 2 equation, m is equal because before increasing the temperature and after increasing the temperature, the mass of iron rod will not be increased, but the volume will be increased, and that's why the density will be increased. Okay, and here, so my dear student, by using all of this equation, I have to find out the final volume of iron rod. Okay, and here you can see that we know that the coefficient of volume expansion gamma equals to V2 minus V1 divided by V1 del T. So V2 minus V1 equals to gamma V1 del T, and V2 equals to V1 plus V1 gamma del T. If I take V1 common, then this equation will be 1 plus gamma del T, and this is our number 3 equation. Okay, and finally, if I divided number 2 equation by number 1 equation, okay, so then I will get rho 2 minus rho 1 equals to m V2 divided by m divided by V1, and rho 2 equals to rho 1 into m divided by V2 into V1 divided by m. If I put the value of V2 from the equation 3 to this equation, then this equation will be look like that, V1 and V2 here, V1 into 1 plus gamma del T into m. M will be cut and V1 will be cut. So the final density rho 2 will be rho 1 divided by 1 plus gamma del T, and If I put all of this value in this equation, then I will get 7800 divided by 1 plus 36 into 10 to the power minus 12, 10 to the power minus 6 into 80. Then I will get row 2 equals to 7777.6 kg per meter cube. So my dear student, here you can see that I have got this value. Okay, that means the final density of the iron rod is 7777.6 kg per meter cube, which is matched with the value of the stem, which is also 7777.6 kg per meter cube. Okay, so I can say that the observation of the student is correct. Okay. My dear student, I hope you enjoyed the class and you have learned all of this creative question which I have already discussed with you. Inshallah, see you again. Assalamu alaikum, my dear student.